Okay, now it's recording. Perfect. All right. All right, we can start then. So let's start with the first exercise. So this is exercise number 1. So this is about section 1.2. Okay, so again, guys, the test is gonna cover. So test. So it's gonna cover sections, 1.2, 1.3, 1.7, and then 1.8. All right, from the textbook. All right, so first question. So we have some equations, and so X, this is supposed to be your input, Y is your output, and you have to determine whether Y is a function of X, right? So we have to determine whether Y, so again, this is the first exercise in the review sheet. So determine whether Y is a function of X. Function of X. All right. So for example, we can, I don't know if we have like time to, to solve all the problems. So I'm gonna just probably pick, let's say like from the first exercise, so we have like 3 different equations, right? For example, let's do the A. Unless there is a specific request, I can probably do the A. Let's start with the A first. All right. So A. So in A, so we have the following equation, right? So it's x squared plus the y squared equals to 5, right? So the idea, guys, you want to determine whether y is a function of x. First, as a first step, you need to solve for y, okay? And then you have to check if, for each x, if there's exactly 1 y. So if for each x there's exactly 1 y, then y would be a function of x. All right, so that's the idea. So as a first step, we need to, so step 1, you need to solve for y. We need to express y in terms of x. So we need to solve for y. Okay, so like in this example, that would be x squared. So we have x squared plus y squared equals to 5. We want to solve for y. So we need, of course, to subtract, let's say, this x squared, right, from both sides. So then your y squared would be 5 minus x squared, right? And then you need to get rid of the square. So we apply the square root. So I'm going to just write again y squared. So which is 5 minus x squared. So we apply square root both sides, right? So just be careful here, guys. On the left side, this is not equal to square root of 5 minus x. That's not true, okay? So you cannot just apply the square root to each term, okay? Because it's a subtraction. If it was multiplication, then yes. If it was like square root of 5 times x squared, then yes, that will be like square root of 5 times x, okay? Because that's a multiplication, right? But here we have a subtraction. Sorry, is there any question? Okay, probably not. So yeah, anyway, so now you're because you see the thing, guys, here is you have the even power. So if you have even power, then actually you're gonna need a plus or minus in front of the square root, okay, because of the even power. So then your y would be plus or minus square root of 5 minus x squared, okay? And so yeah, so that's my y. Now in the second step, I need to check if for each x there's exactly 1 y. So for each input, or for each x, there's exactly 1 output. there's exactly one output y. Okay, so as you can see, well, you can just say, well, because of the plus or minus, right? Because of this plus or minus, actually, for each x, you're going to have two possible outputs or two possible answers, right? So, so here in this case, so for each x, there are two possible answers. For example, I mean, you can take an example, random value of x. For example, if x is 0, then y, the output y would be plus or minus square root of 5, right? So there are two possible outputs because of the plus or minus, two possible outputs. So then y is not, it's not a function of x. Okay. So of course, this is different from the B. In B, the power of y is actually odd, right? It's y cubed in B. So let me just say a couple of words about B. In B, it's the same thing. I mean, it's the same. We follow the same steps, right? So it's minus x squared, y cubed plus 4 equals to 1. So again, as the first step, you're supposed to solve for y. Okay. So when you solve for y in this first step, so you're gonna end up with y cubed, let's say, equal to y cubed would be equal to 3 minus x cubed. Sorry, minus x squared, right? And then when I get rid of the cube, so then you apply the third root. 3 minus x squared. So you apply the third root.
Hey, excuse me.
Yes, please.
For the first one, for A, do we just
Yes.
leave it as y equals plus minus square root 5 minus x squared?
Yes. I mean, there is nothing else to do here. I mean, that's the, I mean, yeah, we leave it like that. Yeah.
And since there were plus minus, is it not a function?
Yes, that's because, yeah, because of the plus or minus, it's not a function. Yeah.
Okay, then got it.
And yeah, so in B, it's in B, as you can see, there's this the y, it's a y cube, so the power here is odd, and because of that, so here the y cube, so the powers is odd, and when the power is odd and you apply like your nth root, so like in this case that will be the third root, right? I'm supposed to apply the third root to get rid of the cube. Of course, you apply the same thing on the right side, but then because of the power is odd, there will be no plus or minus. Okay, so
Professor, I have a question.
Yes, please.
Where did you get the 3 from? 4 minus 1.
Yes, because that's a 4 minus 1. I just I think I jumped like 1 or 2 steps here. Because we don't have really time to to give like to cover all the problems. So I'm just trying to.
I understand, but if you do that, I think
but
then it's supposed to be plus x squared because you gotta cancel out the minus x on the other side, so you gotta add x squared.
No, it's because it's a minus y cube. So because it's minus y cube, you can you can just add plus y cube to both sides. Okay, and then you subtract 1. So that will be 3. So 4 minus 1 will be 3, and on the left side it's minus x squared. Right. This is, I mean, this is actually different from A because here we have minus y cube. That's why it's minus x squared. You see what I'm saying? That's different from A. A, we had like plus y squared. This is minus y cube. So because of the minus, it's actually minus x squared. It's not plus x squared.
Okay.
Um,
I'm sorry, I have a question.
yes, yeah, please.
So then why is the x squared still negative once you move it to the other side?
No, I didn't move it. That's the thing. I didn't move it to the other side. Okay, you know what? I can probably give you more details here. The thing is, so this is minus x squared, right? Minus y cubed plus 4 equals to 1, right? The thing is, this is minus y cubed. So to make it positive, I mean, there are different ways here to make this y cube positive. But one of the ways would be just to add y cube plus y cube to both sides. Okay. So then that will be minus x squared, right? Plus 4 equals to 1 plus y cubed. Right. And then I'm gonna just subtract 1 from both sides. So that's like minus x squared plus 3 equals to y cubed. You see? And again, this is different from A because in A, I had plus y squared, right? It's plus. So I didn't have to, like change the sign of the y square. That's why I just subtracted the x squared and then, and then I got my y. But here, it's just because it's a minus y cube instead of plus y cube. That's why. Does this answer your question? You see the difference with A? So yeah, so then your y cube is actually, as I said, it's 3 minus x squared or minus x squared plus 3, right? And then, as I said, you need to get rid of the cube, so you apply this third root. So I'm gonna just apply here the third root, both sides. And because this power is odd, so there is no plus or minus. Okay, so it's just y equals to the third root of 3 minus x squared. Right. So, and because it's there's no plus or minus, then actually y is going to be, so as a step number two, so as you can see, there's no plus or minus. So if you take any random value of x, there will be exactly one output y. So y is actually a function of x. So y is a function of x.
Excuse me.
Yes, please.
So for C, just by looking at it, there's a y squared. Would that not be a function because you'd have to have?
Well, no, actually it's not. Yeah, you're right. It's not. But the thing is, you need to be careful. C is kind of different from the A and B. The thing is, in the C, we have like two terms with y's, right? Like you have this y squared and you have this 2y, right? Like in A and B, we had only one y. Like we had like just y squared in A and minus y cubed in B. In C, it's a little bit different because we have two terms in y. But you're right. Because of that, because of the square, yeah, the y is actually it won't be a function of x. You're right. Yeah. So let me just say a couple of words about the C, because it's kind of different from A and B. So let me just explain the C. So here's y squared minus 2y minus x equals to 2. So as you said, so we expect y won't be a function of x. But the reason is, so I mean, if we just follow the steps. So in step 1, you're supposed to solve for y, etc. So like you have y squared, minus 2y minus x equals to 2. Here, like this is plus y squared, so I'm gonna just keep the y on the left side. We can probably add x to both sides, you know, so this is like y squared minus 2y equals to 2 plus x. Now the left side, as you can see, it's not just one. Oh yeah, be careful, guys. This is not like this is not like this is not equal to, for example, to minus y, or you are not allowed to subtract the powers here. Okay, so it's y squared minus 2y. So y has like different exponents, right? So when you have like different exponents, you cannot really combine the two y's. You cannot subtract them or add them, okay? Because they have like different exponents, all right? So that, just be careful with that. So here we cannot, just a remark. So y has like different exponents, and because y has different exponents, we cannot combine. So has different exponents, right? So we cannot combine the y's. Okay, we cannot subtract them, or we can't do anything here. Well, except we can do one thing. We can y is a common factor, right? We do have y here and y here, so we can factor out the y. Okay, so that's y would be a common factor, so we can factorize. So if we can factorize, for example, let's say y, there'll be times. To get y squared, we need to multiply y by y, right? And then there's this minus, so here's my minus, and then this is 2y. So if you pull out the y, you're left with 2, right? That's minus 2 equals to 2 plus x, all right? Now, so that's like the best thing I can do here. I can just factor the y. Now, in the second step, I'm supposed to check, you know, if for each x there is exactly one y, right? That's the idea. Here, I don't really have like plus or minus. Okay, so it's not really similar to the b or the a. Okay, here we don't have really plus or minus, but the thing is, if you take some random value of x, for example, I'm gonna take x equal to -2. So why did I pick -2? Well, it's because if my x is -2, as you can see, the right side is gonna be 0, right? 2 plus -2, that would be 0. And that's kind of, you know, if you get 0, that's like the simplest number, right? That will be 0. So if my x is -2, the y, we're gonna have like an equation, right? That we're gonna have like y times y minus 2 equal to 0, right? Now, how many solutions or how many possible answers we have here? If y times y minus 2 is equal to 0, what will be the solutions here? Well, you know, here we have a multiplication, right? We are multiplying two numbers or two factors, y times this y minus 2, right? We are multiplying two factors, and the answer is 0. So when you multiply two factors and the answer is 0, it means that one of the factors or one of the numbers must be 0. Okay, that's the only way to get 0. If you multiply two numbers, like 5 times something else, and you get 0, the something else must be 0, right? So 5 times, that's the only way to get 0. 5 times 0 would be 0. So when you multiply two numbers, the only way to get 0 is one of the numbers or one of the factors is 0. So either the y is 0, the first factor, this factor right here, either the y is 0 or the second factor is 0. This one right here. Okay, or the y minus 2 is 0. So here we are saying like we can have like two possible answers. If my x is -2, we can have like either y is 0 or y is, y minus 2 is 0, then y would be positive 2, right? 2 minus 2 would be 0. So y is positive 2. Right? So as you can see, if my x is negative 2, right, then I got two possible outputs, y equal to 0 or y equals to 2, right? So then y is not a function of x. So then y is actually not a function of x.
Professor,
Please.
so on the test, when
Yeah.
we determine that y is not a function of x, do we have to
Mhm.
lay it out the way you just did? Or if we
Yes.
intuitively know it, then we can just,
Yeah, you need to do it as like the way I did it here, like for
Gotcha.
this example, okay? Because you need to show the reason why, you have to justify your answer, right? You cannot just say, well, it's because it's just a square. Well, then it's not a function, right? You need to give more detail, right? So that's what I'm doing here. This is like the details of my answer. Why for each x is like, you can have like two possible answers.
thank you, sir, no problem.
And again, this is different from like the a. In a, we had the square y square, but then it's clear because of the plus or minus, it was kind of clear. Then it's not, y is not a function. But here, you don't really see them plus or minus, right? It's like there's no, you don't see the plus or minus, right? So we have to explain. You have to justify your answer. All right. Any other question, guys?
Hey, can you just go over D really fast? Because I was
Oh
having
yeah.
I was having a lot of trouble with
Yes.
that.
Yeah, then you have a lot to cover. I know. Okay, let me see. That's why I was saying
Yeah.
you're probably gonna jump some steps sometimes. All right,
It's
so
okay.
for D, just okay, a couple of words about D. The D, guys, when you have a graph and you want to see or want to determine if the graph is a function or if the graph represents a function or not, you have to use the vertical line test. Okay, for graphs, let me just remind you here. So for graphs, you need to use the vertical line test to determine whether y is a function of x. Right. So like in D, so in the review sheet, we have this graph, whether y is a function of x. So just to remind you the vertical line test. So in order to be a function, each vertical line has to intersect the graph at no more than 1 point. Okay, so each vertical line has to intersect the graph at no more than 1 point. The graph at no more than 1 point. All right. So like here in D, of course, if you take any vertical line is going to intersect the graph at no more than 1 point. So then y is a function of x, right? So like in the exercise in D, so y is a function of x, right? Because of this vertical line test. All right, guys. Is there any question about the first exercise? All right, so let's move to the number 2. As we said, I mean, we don't have much time. So number 2, this is an important problem, actually. Number 2, exercise number 2. Yeah, the domain of functions. All right, so number 2. So we have to find the domain of the functions f and g, f plus g, etc. Right? So you start with f. F, it's a square root, right? So when you see a square root, guys, just to remind you, so square root, you want to find the domain, right? You want to find the domain. Okay, so if you see a square root, Okay, then you have to solve what's under the square root. Just what's under the square root, okay? You don't really care about what's outside the square root, so solve what's under the square root, right? Larger or equal to 0. Okay, now if you have a fraction, you know, for example, you have a fraction, so then you have to solve the denominator equal to 0. All right, this thing here, denominator equal to 0, and you exclude the solutions from the domain. Exclude the solutions from the domain. Anyway, so that's the idea. Okay, it's either square root or a fraction. In A, so F, let me just write down here. So in A, your F is like, what's F? Yeah, it's a square root of this x plus 5, right? So all you have to do, guys, let me see, are there any questions in the chat? No, okay. Also, all you have to do, because it's a square root, you take what's under the square root, this x plus 5, and you just solve this x plus 5, right? Larger or equal to 0. Like in this case, it would be just, you know, your x would be just larger or equal to -5. And in your final answer, don't forget to use the interval notation, right? So for the answer, you can use a number line, you know, it's just to make sure that you have the correct answer. You can use a number line, but your final answer should be in interval notation, right? So like, you know, this is your number line, you have your -5, and you're saying your x is larger or equal to -5. Okay, so your final answer should be, so domain of f, d subscript f, domain of f, that will be -5, you know, positive infinity. -5, of course, is included, right? Because this is x can be equal to -5. All right. So next, where is it? Yeah, g. G, same thing, right? It's also square root. Just the g. So this is b. So your g is. Guys, please interrupt me if you have any question. All right. So this is 4 minus x minus 2. Again, it's a square root, and under the square root is 4 minus x. I don't care about the -2. So we have to solve this 4 minus x larger or equal to 0. Here you need to be careful, guys, because it's a minus x. That's not plus x. It's not like an a. Okay, so just be careful. So because it's a minus x, I'm gonna. I mean, there are different ways again to make this minus x plus x, and I would say probably the easiest way is just to add plus x both sides, right? And then your 4 would be larger or equal to x. Okay, so 4 is larger than x. So in other words, x would be less. Your x is actually less than or equal to 4. So final answer. Oops, final answer. So domain of the g, it's just it's less than, sorry, it's less than 4. You know, you have this is 4, you have this is negative infinity, positive infinity. It's less than 4, so it should be on the left side of 4. Sorry. All right. So domain of g would be, you always go from left to right, guys. Okay. Don't forget that's it's always from left to right. So you start from the left, it's negative infinity all the way to 4. 4 included, infinity is always excluded, right? Now for the C, the F plus G. So in the C, F
Hey,
plus G.
quick question.
Yeah, please.
For B, you only have to worry about what's inside the square root. You don't have to worry about that -2.
What's in, yeah, absolutely. Yeah.
Okay, got it.
Yeah. However, in D, we're gonna take into account the -2. But yes, for this for the B, just for the domain of G, you don't care about the -2. Yes. For the F plus G, guys, now you don't have to compute F plus G. The idea here, it's not to compute the F plus G. You don't really care about the F plus G or F minus G or F times G. All you have to do is just to find the common domain. Okay, so we need to find the common domain. And that will be the domain of F plus G. So you don't waste your time computing the f plus g. Okay, so don't compute the f plus g. You don't have to compute the f plus g. Okay, so we need to find the intersection domain, right? So here is my number line. Domain of f, we said it's -5, positive infinity. Domain of f, it's -5. -5, positive infinity. This is the domain of f, right? And then domain of g would be negative infinity, +4. So domain of g, it's the other way, negative infinity, +4. So this blue interval, that will be the domain of g, right? Now we need to take the intersection or the common domain. That will be the intersection of the two intervals. And as you can see, the intersection of the two intervals, that's the interval which is at the same time red and blue, right? So that will be this interval right here. Okay, that will be my intersection or common domain. So yes, so then a domain of f plus g. So I'm using the a and b, right? So probably in the test, you're gonna have the same thing. Like you wanna find the domain of a, you wanna find the domain of f, find domain of g, and then in C, you will have to find like domain of f plus g or f minus g or whatever, right? All you have to do, guys, use the a and b, find the intersection domain. So like in this case, that will be -5, 4, and both -4 and 5, -5 and 4 are included. Okay. Now for the D and E, yeah, just you have to be careful the fraction when you divide f by g or g by f. So like in D, the domain of f over g, okay? So all you have to do, guys, because we are dividing by g, right? So we are not allowed to, of course, we are not allowed to divide by 0. So we need to exclude the values of x where g is, yes, yeah.
I'm sorry. I know you want to get through everything, but you're talking really fast. I don't know
Really
if I'm the
fast.
only one,
Okay,
but
sorry. Sorry.
yeah.
Sorry about that. All right. Yeah, I was saying because we are dividing by g, so we need to exclude the values where g of x is 0. Okay, because we are not allowed to divide by 0. So we need to exclude the values of where the values of x where g is 0. So where g of x is 0. Okay, and we need to exclude those values from the common domain. We need to solve, because we are dividing by g, so then we need to solve g of x equal to 0. So we need to solve g of x equal to 0. So g of x, now I have to take the whole expression. So that will be the square root of 4 minus x, and then the -2. Okay, that's the whole function, right? Equal to 0. Okay, so as you can see here, we have to take into account the -2. Okay. All right, the way to solve this, well, you cannot really touch the square root. We need first to get rid of this -2. So we're gonna add +2. All right, so then, so this is actually equal to square root of 4 minus x equals to 2. We need to take now the square to get rid of the square root. 4 minus x equals to 2 times 2, right? 2 squared 4, and then subtract 4. So then minus x would be 0. Right, and then, get rid of the minus, just so you can multiply or divide by -1, is up to you guys. Let's say you're gonna multiply by -1, both sides, of course. And once you multiply by -1, you get plus x. So that's x equal to, of course, 0 times wherever is going to be just 0. So the solution here is 0. So we need to exclude the 0 from the common domain. So we exclude the 0. From the intersection or from the common domain. All right. So again, my common domain was this negative 5, 4, right? That's my common domain. So I need to exclude the 0 from negative 5, 4. So 0, of course, it's between, between negative 5 and 4. So we have to stop, at 0. So my domain of f over g. So here's the answer. Domain of subscript f over g. So we start at negative 5, all right, included. And then, as I said, we have to exclude the 0. So we have to stop at 0, excluded, and then start again at 0, union, right? 0 to positive 4, included. 4, of course, is included, right? Any question about the D, guys? So when you have like f over g or g over f, guys, there's one more thing to do. You have to solve your denominator equal to 0, and you exclude the answers from your common or intersection domain. For the g over f, for E, the difference between D and E, in E, the denominator is given by f, right? And E, so here in E, it's g over f, right? So in this case, we are dividing by f, right? So we are dividing by f. So that's why by f. So that's why we need to solve. So in E, we need to solve f of x equal to 0, not g of x. Okay, so that's the difference between D and E. In D, we solve g of x equal to 0, and you exclude the answer from the common domain. In E, we solve the f equal to 0. Okay, so I'm gonna jump the steps here, guys, unless you have trouble with the E. But if you solve f of x equal to 0, x, the solution would be 5, right? And so the answer, again, I'm jumping steps here, guys. I'm just trying to, I'm gonna try to cover everything. So this g over f would be, so we need to exclude the 5 from the common domain, right? Exclude this from the common domain. Right? Again, my common domain is just the negative 5, 4, right? We need to exclude the, sorry, I said the negative 5. Sorry, this is negative 5, sorry. So my common domain is negative 5, 4. So we need to exclude the negative 5, right? So the answer here for the domain of g over f would be negative 5 excluded, and then 4 included, of course. Okay. Any question, guys, about this exercise number 2 for the domains of f, g, f plus g? Of course, if you a domain of f plus g would be the same domain as f minus g and f times g. Okay, so just to remind you, so the domains of f plus g or f minus g or f times g, it's just the same domain. It's the intersection domain or the common domain. So they're just the same thing, the common domain. Right, let me check the chat if there's any question in the chat. Sorry, I'm going kind of fast, so all right. Okay, I guess there are no questions. I don't see anything in the chat. All right. Okay, so let's move. Unless, again, if you have a question, guys, let's move to the number 3. All right, exercise number 3. All right, so we have this graph of the function f, and you have to determine each of the following. So we have the range. You have to find the range, right? x-intercept, etc. So let me start with the range. Okay. Okay, let's do the range and then we'll see. All right, so let me just I'm gonna graph again the function f. So the graph looks like the following. I'm gonna just go fast, guys. So I'm sorry if the graph is not clear. This is 4, -4. This is 1 right here. We have like 4 right here. All right, that's all I need actually. So the graph of f looks like the following. All right, so this is like goes up here, and then it passes through the +1, and then it goes to the down here. So I guess this is, yeah, this is the graph of f. All right, the range, guys. Want to find the range of a function using the graph. So we have to use, I'm going to need negative infinity right here and positive infinity. So for the range, guys, we have to use horizontal lines. And you need to go from the bottom to the top. Use horizontal lines. And so if the idea is that if your horizontal line intersect the graph, then your y is going to be is included in the range. Okay. So if there's intersection, then y is in the range. Then y is in the range. All right, so let's do this. As I said, you go from the bottom to the top. So I'm gonna go, you start at negative infinity, of course. All right, so here, right here at the level of negative infinity, as you can see, actually I intersect the graph, like, you know, because the arrows, so it means that the graph actually goes all the way down. So we do have intersection, as you can see, right here. So you start at negative infinity and you do have intersection, which means that this is actually in the range. All right, so whenever you have intersection, it's in the range. So here, this is in the range. It's still in the range, as you can see. You can go all the way up here, +1, still in the range, right? This is still my range. And then I need to stop actually at +4, right? So as you can see here at +4, right here, right? I do have intersection at this point, right? But then after 4, of course, there will be no intersection, right? If you take like this horizontal line, right? There will be no intersection, right? So as you can see, my range is this blue interval, right? So it's from negative infinity to +4. That's my range. Any question, guys, about this, the range of this function f? All right, so
Professor, why
yeah, please.
the range is not from +1 to +4 rather than negative infinity?
Well, because you do have intersection here in the bottom. You see, if you take this, for example, this blue line right here, right? We do have intersection with the graph. I mean, your horizontal line is going to intersect the graph, right?
Oh, got it.
So you see here, you do have intersection here at the bottom. When you are close to negative infinity, you see, if you take any horizontal line, it's going to have intersection. That's why, and as I said, you start from the bottom, and in the bottom, negative infinity, when you're close to negative infinity, you do have intersection. So that's why we have to start, sorry, that's why we have to start at negative infinity. Okay, so yeah, so yeah, so the answer range would be, so we start at negative infinity. Infinity, as I said, infinity, it's not a real number, so we always exclude infinity, okay, no matter what. So negative infinity to +4, which is included, +4 included because of this, you know, because we do have intersection right here, right? So we have to include the +4. Anyone else? Any other question, guys, about the range? So that's for the range. Let's see what else. Next, the x-intercept. Well, the x-intercept, guys, that's by definition, that's the intersection of the graph with the x-axis. So here we do have two x-intercepts, right? Because we have an intersection at -4 and at +4, right? So these 2 points are my x-intercepts. This is my x-intercept, and here my x-intercept. So again, x-intercept, it's just the intersection of the graph with your x-axis. This is supposed to be my horizontal axis. This is supposed to be my x-axis, all right? So, and for the answer, guys, your answer has to be in points notation. So for the x-intercepts, so the x-intercepts are, so we have -4. Okay, so then it's -4, 0. It means the point with coordinates -4 and y equal to 0. Y is always 0 for the x-intercept. And the other point is 4, right? So that will be 4, 0. The y-intercept, guys, that's the intersection of the graph with the y-axis. The y-axis, that's the vertical axis, right? This is my y-axis. So as you can see, the intersection, let's pick a different color, blue, let's say, not blue, green. All right, so as you can see, we do have intersection here, the intersection of the graph with the y-axis, and the intersection is actually at 1, right? This is supposed to be, sorry, it's a mess now, but that's supposed to be y equals to 1, right? So for the y-intercept, the answer, so the y is 1. So for the y-intercept, is your y-intercept x is always 0, comma, y is equal to 1. All right. Any question, guys, about the y-intercept? Okay, probably not. All right, cool. Now next, yeah, so we have to find like the values of f of -2, etc. All right. I need to graph again. I'm sorry. I need to graph again the function f. So like here, this is -4, -2 right here. This is 1. This is 4. Sorry about that, guys. So this is, yeah. We have this point right here, something like this right here, and all the way down right here. All right. This is f of x. So for example, if you want to find f of -2, so f of -2 means you need to find the corresponding output y. My input is -2. So f of -2, my x is -2, right? This is my x. And I need to find the corresponding output y. So x is -2, it's right here, right? This is x is -2, right? That's my x-axis. And then I need to find the corresponding y. And the way to find the corresponding y is to use, vertical lines. So I'm gonna draw like a vertical line starting from -2, and you need to find the intersection with the graph, right? So the intersection of the graph is gonna be this point right here, which corresponds to, as you can see, +4, right? So what I'm saying is, if my x is -2, then my y, corresponding output y, is +4, right? So the answer here is +4. Okay, now we have like this composition of functions, right? So let me do one of them. You have like f composed with f. Yeah, it's always f composed with f. All right, so let's do f composed with f of 4. So this is f composed with f of 4. So right here, guys, there are like 2 steps, and this circle means it's not a multiplication, it's not a product. This means composition, right? We compose f with itself, composition. Okay, so in other words, so what we are looking for is So we have f of 4. So we need, first we need to find the f of 4. So this thing here inside the parentheses, right? So we need to find f of 4 first, right? So what's f of 4? X is 4. So here's my x equal to 4, right? This is my x equal to 4 right here. Now, if you take a vertical line starting from 4, so where does it intersect the graph? Well, actually, as you can see, the point lies on the graph, right? So it's just the intersection would be just the same point. And the corresponding y is actually 0, right? So f of 4 is 0. So what's inside the parentheses? It's a 0. So we have like f, there's an f outside, right? There are like two f's. So there's an f outside the parentheses and there's an f inside. So f inside the parentheses applied to 4, that will be 0. And now the next step or second step, we need to find f of 0, right? So now f of 0, so my x is 0. Let me see right here. This is my x equal to 0. So then the corresponding y, you know, again, you're supposed to go with a vertical line. And as you can see, it's going to intersect the graph right here. And the corresponding output y is 1, right? This is y here is equal to 1. So the answer here would be 1. F of 0 is 1, right? So whenever you see like a composition, guys, like have like f composed with f, so there are like two steps, right? First, you need to do what's inside the parentheses. Like here we had like f of 4. Once you are done with the f of 4, then you need to apply f again, or the second function, which is outside the parentheses. Is there any question, guys? I mean, of course, the f, I mean, no, let me see what is the, so we have f of composed with f of -2, etc. I mean, again, it's just the same idea, right? I can probably move to the next problem unless like there's a specific request, or if you have any trouble with this composition, guys, just let me know, right? Okay, well, probably we can move to the next problem or exercise. So exercise number 4, we still have like 50 minutes. Okay, that's good. We have time. All right, cover everything. All right, that's good. So for exercise number 4, guys, even, yeah, we need to see if the function is even, odd, or neither. So I'm gonna just remind you first what we have to do in this case. So f of x is even if f of minus x is equal to f of x. All right, and f is odd if f of minus x is actually equal to minus the opposite of f of x. So the minus would be outside the function f, right? And the idea here, guys, so if all the powers of x are even, then your function is going to be even. If all the exponents of x are odd, then the function is going to be odd, right? And if you have like a mixture of odd and even, then your function is neither. Okay, that's like the idea. But of course, in the test, guys, you have to justify your answer. Okay, if you just write, if you write down like all my exponents are odd, so then my function is odd, you won't get full credit. Okay, so you have really to justify your answer. So the way to justify your answer is, for example, for the first one, we have, let's do, let's say the first, the f of x, which is x cubed, right, minus x. Okay, so as a first step, guys, you have to find f of minus x, right? You have to find f of minus x, but then once you find f of minus x, you can compare it to f of x or to minus f of x, right? So always, the first step is always to find or compute the f of minus x. That's always the first step. It doesn't matter if you're checking if the function is even or odd. The first step is always the same. So it's you need to find first f of minus x. All right, that's always the first step. Well, of course, I mean, if you want to make a guess here, our guess would be that this function f. Any guess, guys? You think it's odd or even or neither?
That's odd.
Odd, yeah, absolutely, because well, this is 3, this is odd, and this x here is like x to the power 1, right? X power 1, guys, is x to the power 0, it's actually 1. Okay, so yeah, both 3 and 1 are odd numbers, so that's why the function is going to be odd. But anyway, so to justify my answer, first I'm going to go with the first. I have to compute this f of minus x. So I'm going to write down first f of x, which is actually x cubed minus x. That's my f of x. And now I'm going to evaluate f of minus x. So I need to substitute x with a minus x, right? This is an x in here, and there's an x in here. Okay, so both x's, they're going to become minus x. So so this is equal to, so this x here is going to be minus x, and the same for this x. So this is like, so we're going to have minus x right here and minus x right here. Again, my guys, again, guys, my advice for you is, you know, to always use this parentheses or circles, okay? Because otherwise it's easy to get confused, okay? So like here, there's this cube, oops. So there's this cube, all right? And there's this minus, okay? So as you can see, there's a minus between the two terms here, and there's a minus inside the circle, right? So so if you use parentheses, so it's going to be like minus x cubed minus, and then parentheses minus x, right? Now thumb test rule, guys. So you you know, you have a subtraction, and you have like a power or exponent, right? So first we need to do the exponent, right? So that's like we have to evaluate minus x cubed, right? That's my my exponent. So minus x cubed, this is like minus x times minus x times minus x 3 times. All right. And the rule, guys, if you have a odd power, then you're gonna end up with a minus. If you have even power, then you're gonna end up with a plus. So like here, this is minus x cubed, right? 3 is odd. All right, so we're gonna end up with minus x cubed without the parentheses. Okay, because it's the power is odd. But if you had like minus x to the power 6, for example, if you have like minus x to the power 6, because the power is even, right? This 6, of course, is even, then you're going to end up with plus. So this is going to be equal to plus, you know, plus x cubed, which is just x cubed, of course. This is plus x cubed or just x cubed. Okay. Odd power, there's a minus at the answer. Even power, it's just a plus. All right, so that's like the rule. And now, so this thing here, let me just come back to this. I'm gonna probably erase this. I'm sorry about that. Yeah, so yeah, so I was saying this is odd. So we're gonna end up with minus x cubed. All right, and then guys, as you can see, there's minus minus. So that will be a plus, right? So it's plus x, minus x cubed plus x. Okay, so that's the final answer. That's my f of minus x. It's minus x cubed plus x. Now, in the second step, we need to compare f of minus x to f of x, or and minus f of x. Okay. So if f of minus x, for example, is equal to f of x, then your function is even. And if f of minus x is equal to minus f of x, then your function is odd. Okay, so anyway, so let's compare. Let's see. So my f of, let me just write it down here. My f of minus x, which is from the first step, minus x cubed plus x. What's f of x? F of x, this is just my original, my original function, right? Which is original function, it's x cubed minus, it's x cubed minus x, right? So it's x cubed minus x. This is x cubed minus x. That's my original function, right? Now, what's minus f of x? So there'll be a minus, and then it's minus the whole function f, not just like the first term of the function f. It's minus the whole function f, right? Minus the whole function f. So minus my function f is, x cubed minus x. All right, and again, you think of the circle as parentheses. So this is actually equal to, well, minus x cubed, and then minus x, that will be a plus x. So the answer here for minus f of x, that will be minus x cubed plus, right, minus, that will be a plus x, right? Because, again, because of this minus, and you have minus outside your parentheses or your circle, so that will be a plus. So yeah, so we need to compare now. My f of, this is my f of minus x, right? So first question is f of minus x, is it equal to f of x? Well, this is f, this is, here's my f of minus x, and here's my f of x. Are they equal? Nope, right? Because it's minus x cubed, and the in f of x, it's a plus x cubed, so they're not equal. So the answer is no. And because the answer is no, it means that the function is, it's not even. So f is not even. So f x, it's not even, right? And then the second question, we have to compare this f of minus x, if it's equal to f of minus f of x, to minus f of x. Right, so let's see. So again, this is my f of minus x, and here's my minus f of x. And as you can see, they are equal, right? So yeah, so then the answer is yes. And the answer, if the answer is yes to this question, it means that f is odd. So f of x is odd, as expected. Okay.
Professor,
Yes,
I have a
please.
question.
Yeah.
If we don't want to do all these steps, like by just looking at it, we could tell if f of x is even or odd. Like,
Just
or
from
like what
exponent?
portion of the grade are you going to give us? 50%?
Well, I don't know. It depends on the grade. But for sure, you're gonna get just partial credits. I don't know.
It could be half grade, half credit, right?
Well, I don't know.
This is a very important question.
Yeah, honestly, because I personally, I don't think like I could really go through all of this.
No, it's not. I mean, if you just follow the steps, I mean, it's not really bad. It's not really bad. I mean, first you find this f of minus x, just replace your x by minus x, right? And the step two, just write down your answer from the first step. You compare it to your original function f, and then you compare it to the opposite of your function f. I mean, well, I mean, I can't really promise, but yeah, I don't know how much. I mean, I can't promise anything. I mean, I can't really promise you.
Okay, another question.
But for sure, you're gonna get partial credits. Sorry.
Okay, and another question as well.
Yes, please.
Like the review sheet that you gave us, right, and the
Mhm.
exam, is it
Mhm.
technically going to be like the same strategy, the same everything, but just different digits, or are you gonna change it?
No, I can't really say, but I can't really say. But yes, the idea is, but I mean, this is like just a standard problems. You know, standard problems. It means like you always like get these problems in the test, in any pre-calc test. So these like standard problems. So yeah, you expect to have like a similar problems, but I can't say if it's exactly the same thing or like different digits or whatever. Okay, but yeah, you should expect like something very similar.
Okay, but it's gonna be like the same steps to
Yeah.
the solution.
Yeah, of course. Oh yeah. Of
Okay.
course. Oh yeah, sure. Yep. Any other question, guys? All right. So, okay. So that's for the even, odd, neither. Let's move to the next problem, unless you want me to solve another function f. So we can probably cover everything. I can come back to this. I mean, if we finish the next problems.
I agree. I
Uh,
think we should go to 5.
Yeah. I'm gonna do my best. Okay, so all right, so let's do the 5. Five. All right. So the inverse, yeah. Okay, we did this like I think Wednesday last week, right? The inverse of the function f. You need to find the inverse. Find the inverse. I'm gonna remind you. Let's find the inverse. Sorry. So here's my function f, which is what is it? So it's x minus 3 over 4 plus 5x. All right. So first step, you replace f of x by y. So that will be y equal to like x minus 3 over 4 plus 5x. Next step, you switch or interchange the x and y. So that will be y becomes x and x becomes y. So this is y now. There's y in the top. Both x's. You replace both x's by y, guys. If you just replace one x by y and you leave the other one as x, then probably you're gonna end up with the wrong answer. Okay, so both x's, you replace both x's by y. So this is y minus 3, and this is 4 plus 5y. All right. Now, I would say now the last step and the most important step, actually, you need to solve for y. That's how you get the inverse. You solve for y. Okay, so now, I think we discussed this, Wednesday last week, but let me just remind you. So we have like this x equal to y minus 3 over 4 plus 5y. All right. All right. So what you can do, guys, whenever you have two equal fractions, you can always cross multiply. So left side doesn't look like a fraction, but you can just divide the x by 1. So I'm gonna divide the x by 1. So now on the left side, I have a fraction, right? X over 1, of course, is just x. You can always divide by 1. It doesn't change your expression, right? So now I have two equal fractions. All you have to do, guys, just cross multiply. So you cross multiply like this, right? And when you cross multiply, you get like x times this 4 plus 5y. And then on the other side, we have like 1 equal to 1 times this y minus 3. We are allowed to cross multiply, guys, here because the ratio of the two fractions is the same. Okay, that's the idea. That's why we can cross multiply, and that will be equal. Now, of course, I'm gonna solve for y. Well, first, I can distribute, this is, this x times 4, and this then x times this 5y. Don't forget the 5, it's 5y, it's not just y. So this is like x times 4, that would be 4x. And then there's this plus, right? So I'm gonna put my plus, it's 5y times x. So we need the 5, and then there's x and y. All right, that's the left side. The right side, because it's just times 1, it's going to be just the same thing, y minus 3. All right, now the problem, guys, we got a y on the left, a y on the right. So the idea is to move all the y's on the same side. And once you move all the y's on the same side, then you can, y would be a common factor, so you can factor out the y. So for example, we can, so what I mean by moving the y's on the same side, you can, for example, let's say subtract y from both sides. So if you do this, then you're gonna have like 4x plus 5xy minus y equal to, and here, of course, y cancel out. So that's what I mean by moving the y's on the same side, right? So now on the right side, it's just negative b. So that's the idea. So we got our y's on the same side, so we can factor out the y. Okay, so here y would be a common factor. So I can factor out my y. So times. So here, if you pull out the y, you're left with 5x, right? There's this 5x right here. There's this minus. So here's my minus. And if you pull out y, you have y right here. So this is like 1 times y. So if you pull out y, you are left with 1. Right? If you pull out this y here, you're left with 1, right? And there's this 4x, of course, plus, and here's negative. So, well, I want to solve for y. There's this 4x on the left side. So I need to get rid of this 4x first, and then I can divide by this 5x minus 1. So let's get rid of this 4x. So then y times 5x minus 1 equal to, so minus 3 minus 4x. Okay. So now, guys, I can, you see why I subtracted 4x? Because now I can divide by this 5x minus 1. Right, so it's gonna cancel out. And of course, you have to do the same thing on the right side. So here it's divided by, it's also divided by 5x minus 1, right? And now I got my y, which is, I got my y, which is equal to minus 3 minus 4x over 5x minus 1. So that will be your F inverse. So the answer, F inverse, negative 3 minus 4x over 5x minus 1. All right, guys. Is there any question about this? Let me see the chat. Okay, there's nothing in the chat.
I have a quick
Yes.
question.
Yeah, please.
For that inverse, if I left it as y equals negative 3 minus 4x over 5x minus 1. If I left it like that instead of writing the f minus 1, will you deduct?
Yeah, you get full credit. Yeah.
Okay.
You get full credit. Yeah. I'm just trying to explain that this is like the fine answer, Yeah, the F inverse. Yeah. Any other question, guys? Okay, probably not. Okay, perfect. All right. So let's move to the next. Oh yeah, the domain of F composed with G. This is another. This is another important problem. Okay, I can probably just move to the next page. All right. Yes, this is number 6. Okay, exercise number 6. F think how many are left? Let's see. So 6. As I said, 7. 7. This is section 2.1, and it's not in the test, so you can just ignore the problem number 7. So there's only one more problem left, which is in problem 8, which is kind of what we did in the problem 4, I think. But anyway, so let's do the 6 first. All right. So in the 6, so we have So we have this f, which is this 3 minus 2x over x plus 1. And you have the g, which is 2 over x plus 1. All right, so we need to find domain of f composed with g and domain of g composed with f. So let's start with the f domain of f composed with g. F composed with g. All right, guys, so the steps here. First step, you start with, in the first step, you start with the domain of the second function, which is g, right? The g is the second function right here. So step 1, you need to find the domain of g, because that's my second function. My second function. Like if you want to find the domain of g or g composed with f, for example, you have g composed with f, then because f would be in the second function, right? So then in the first step, you have to find the domain of f, not the domain of g, right? So the first step, we'll always find the domain of the second function, right? Yeah, what's the domain of g? Well, g is just 2 over x plus 1, right? So find domain of g. It's for g as a fraction. So when we have a fraction, we have to solve the denominator equal to 0, right? So this is a fraction. And when we have a fraction, as we discussed in the problem number 2, we have to solve the denominator. We have to solve the denominator equal to 0. So, all right, so the denominator here is just x plus 1 equal to 0, right? That's my denominator. It's right here. So your x would be equal to -1. Right? So you exclude this. So you exclude this answer from the domain. Okay. So then the domain of f would be, domain of g would be any number except the -1, right? So domain of g. So the answer here for the first step. So domain of g, it's any number except the -1. So like on your number line, you have to exclude, you have to stop at -1. So you go from -infinity to -1, you exclude the -1, and again, I have another interval, you have to continue after -1, right? So that's -1 positive infinity, right? So your -1, it's excluded. Sorry, excluded. Right, now, as a second step, you need to, so step number 2, you have to simplify this f composed with g and find its domain. So you have to simplify, you have to compute and simplify this f of g of x and find the domain. All right, so we need to compute this f of g of x. So this is first, I'm gonna write down f. It's the 3 minus 2x over the x plus 1. All right, and we need to replace x with the g. So f of g of x. So this is equal, and then so we need to replace both x's. There's an x in the top, an x in the denominator. So both x's we need to replace both x's by g. So there's this 3 minus 2. Now it's times g. And in the denominator, it's now g plus 1. All right, so let's do this. So this is f of g of x. So it's 3 minus 2 times the g. The g is 2 over x plus 1. So let me just explain here, guys. So the 2 here, it's a whole number, right? So you need to think of 2 as, as a numerator. So it's like in the top, it's not in the bottom, because you can write this to like 2 over 1, right? So this is like, so this is like 2 over divided by 1. Okay, so you think of the 2, the whole number 2 as like a fraction with the 2 in the top. Okay, over, so this whole thing, of course, divided by this again, g is the 2 over the x plus 1, and there's this plus 1, and the same thing for plus 1. The 1 is actually like that will be the numerator of a fraction, right? 1 over 1. So it's like in the top. All right, so your f of g of x. So here, guys, this is like a multiplication of 2 fractions, right? This 2 or 2 over 1 times the 2 over x plus 1. So this is a product of 2 fractions. You're multiplying 2 fractions. And the way to multiply fractions, just to multiply straight across. So here you multiply like this 2 times 2 and the 1 times the x plus 1. That's how we multiply fractions. All right, so this is like 3 minus, you multiply, so that's like 2 times 2, that would be 4. And in the denominator, it's like 1 times x plus 1, right? This is like 1 times x plus 1. So that's how we multiply fractions. All right, now, in the denominator, it's a different story, right? It's not multiplication of fractions, it's addition of fractions. So you have this plus. There's this plus here. So it's not multiplication, right? So we cannot just like add the tops and add the denominators, okay? When you add or subtract fractions, you need the common denominator, okay? So what we do, you take like, you take the first denominator, which is x plus 1, okay? And what you do is you multiply the second fraction, the top and the bottom, both, okay? The both by x plus 1. Because that's the denominator of my first fraction. And what we are supposed to do with the first fraction is, because, well, you have 1 as a denominator in the second fraction, we're supposed to multiply the top and the bottom of the first fraction with 1, right? That's how we get the common denominator, okay? All right, so now, so this is just a first fraction, it's 1 times 2, which is of course just 2 over x plus 1 plus, and now this is 1 times x plus 1, so that will be x plus 1, and 1 times x plus 1, of course, is just x plus 1. So as you can see now, guys, I got my common denominator, right, which is this x plus 1. Now, once you get the common denominator, you can add the tops, so you can add this, the 2 plus x plus 1. Right, so let's do this. So your f composed with g. So let me just leave the top, 3 minus 4 over x plus 1. Now in the denominator, as I said, you're gonna add the 2 to the x plus 1. So that's like 2 plus x plus 1 over my common denominator, which is the x plus 1. Okay, now let's come back to the numerator, to the top. In the top now we have like a subtraction. It's a subtraction of 2 fractions. Well, again, the 3, you just divide the 3 by 1 to make it a fraction, right? So you just divide 3 by 1. That's now it's a fraction now, right? So again, it's subtraction or addition fractions. You need to get the common denominator. The way to do it again is you take the denominator of the the second fraction and you multiply the first fraction by the x plus 1. And you're supposed to take the denominator of the first fraction, okay, and you're then multiply the top and the bottom of the second fraction with 1. Okay. So this is now, so your f of g. So we have like 3 times x plus 1, right? 3 times x plus 1. So you need the parentheses for x plus 1, okay? Because it's 3 times the whole x plus 1, not just like 3 times x or just 3 times 1. It's 3 times the whole x plus 1. The same in the bottom. It's 1 times x plus 1. It's just x plus 1, of course. Minus, and this is 4 over my x plus 1. And in the denominator, it's, as you can see, this is 2 plus x plus 1. That will be 3 plus x. And over x plus 1. All right, so as you can see in the numerator, I got my common denominator, right? So all I have to do is just to subtract the tops. So this is f of g. So I'm gonna subtract, so we have like 3 times x plus 1 minus 4 over the x plus 1, which is my common denominator. All right, this is my common denominator. Over the whole thing over another fraction, which is 3 plus x over x plus 1. You can simplify, we can simplify this numerator here, guys, because I can, let me see if there's any question in the chat. Okay, there not. So we can distribute. So 3 times x would be 3x, right? This right here, you can just distribute. And plus 3 times 1, that will be 3 minus 4. And then the whole thing here divided by x plus 1. And then we divide again by 3 plus x over x plus 1. All right. Now 3 minus 4, that will be minus 1. So my f of g, it's now 3x minus 1 over x plus 1 divided by 3 plus x over x plus 1. So you see, guys, when you are done with the top and the denominator, then you can divide your fractions. But first, you have, as you can see, you have to add your fractions, you have to subtract your fractions, etc., etc. When you are done with everything, like subtractions, additions, etc., then you can divide your two fractions. So now the way to divide fractions, of course, you have to flip the denominator. That's like this last step. That's like always the last step. So you have to flip this denominator, right? So you once you arrive to this last step, then you flip. So this is like 3x minus 1. You flip the fraction in the denominator, of course. So it's x plus 1 over 3 plus x. All right, and because it's a multiplication, right? This is multiplication. That's the reason why we can cancel out the x plus 1. Okay, if it was a plus instead of a dot, or a minus instead of a dot, we cannot cancel out the x plus 1. Okay, just be careful, guys. The only way to cancel out is when you have like a product, when you have a multiplication. Anyway, so now it's just so this f of g of x, well, we are done finally. So this is the x minus 1 in the top, and that's just 3 plus x in the denominator. Okay, now we need to find the domain of this. So what's the domain of this? Okay. So it's a fraction, and because it's a fraction, right? This is a fraction, and because it's a fraction, we have to solve the denominator equal to 0, and the denominator, it's just 3 plus x. So we solve the denominator, which is 3 plus x equal to 0. So your x is just -3. right? So the domain here, this f of g of x simplified, it's actually any number except this negative v. So that will be negative infinity, negative v excluded. So this is excluded, right? Negative v is excluded. Union, again, negative v to positive infinity. Right. So that's your second step. Now, in the last step, you take the intersection of the domains in the first and the second. The domain of g in the first step was like, we excluded, I think,
-1.
-1. Thank you. So we excluded -1. Here we have to exclude the -3. So final answer, domain of f composed with g, we exclude both the -1 and the -3. So step 3. So domain of f composed with g, the final answer, that will be the intersection of the domains in the first and the second step. Step 1 and step 2. Step 2. So, which means, so we have to exclude -1 and we exclude the negative v. Right, so final answer. So domain of f subscript f composed with g, that will be negative infinity. We have to stop at negative v because we have to exclude negative v, union -3 to -1 because -1 is excluded, union, okay, -1 to positive infinity. So we have like 3 intervals here, guys, right? Just we have to exclude -1 and -v. So of course, everything on the right side of -1, it's included, and everything on the left side of -v is also included, and everything between -3 and -1, right? Just to exclude -1 and -3. Any question, guys? So this is how we find the domain of f composed with g. This again, the reason is, you know, when you have f composed with g, you have to make sure that your g of x is first is well defined, right? Because you need to make sure that x is the domain of g. So your g of x is well defined, and you need to make sure that the g of x is also in the domain of f. This whole g of x is also in the domain of f. That's what we do in the second step, right? And then we take the intersection. For the domain of g composed with f, guys, I mean that the idea is, again, it's just the same, except that when in the first step, I'm gonna make this remark about the g composed with f, and then I'm gonna check I'm gonna go over number 8. As I said, number 7 is not in the test. So let me just say, for the g composed with f, as a first step, sorry, step 1. So we want to find the domain of g composed with f. So this is very different, actually, very different from f composed with g, because it's like it's different function. Okay, it's just the different functions. So as a step 1, you need to find the domain of f, because that's now it's your second function, right? Because now f is the second function, right? And so like here, of course, well, actually f and g, they have the same denominator, right? So like the domain of f, I mean f of x is 3 minus 2x over x plus 1, because as I said, well, f and g, they have the same denominator. So that's why domain of f is the same as the domain of g. So here we're supposed to solve the x plus 1 equal to 0. So again, your x would be -1. This is just a coincidence, guys. Okay. So because here f and g have the same denominators, but in general, of course, if you have a different denominator, you're gonna get different domain. So like domain of f here would be like, so like domain of f here would be like -infinity, -1, union -1, positive infinity. We had to exclude -1. All right, step number 2, probably I don't have time to do step number 2, but in step number 2, you have to simplify this g composed of f now. Okay, so simplify g composed with f of x. Okay, and find its domain. So this is different from, this second step. It's also different from the second step in f composed with g. This is g composed with f. So we're gonna get like different function. This is different from. So this is different from f composed with g. Oops. Okay, for f of g of x. Okay, so so for f of g, we simplified f of g of x. Here, we need to simplify g of f of x. Okay, so it's different. So you're gonna end up with different function for sure. So which means we're gonna end up with different domain, right? And then as a step number 3. We need to take the intersection. So the domain of g composed with f is the intersection of, again, domains in step 1 and 2. Step 1 and 2. Right, guys. Is there any question? We have like 6 minutes. I guess I can go over finish number 8, and I will see. I mean, if we have a couple of minutes left, I can probably answer. If you have any questions, I can probably answer them. But let me just now discuss number 8. So exercise number 8. I mean, number 8 is just it's very similar to the problem number 2, where we had to find like the g composed with f of, or f composed with f of -2 or whatever. So in this exercise, so we have 2 graphs, right? This is, let me just very quickly graph f and g. Let me see. So what we need, at least for the first one, I'm gonna need probably 2, and then here, this is -5. All right. So let's say here's your f. This is your f of x. And then g is, it's like this right here. This is g of x. Here, I think it's supposed to be 2 right here. All right. So for first, we have to find g composed with f of 0. So we need to find, so here there's no graphing, guys. You don't need to graph anything. So all you need to do is to find this g composed with f of 0, right? So again, the idea is the same. So we have to find, so this is like g of f of 0. All right, so first we need to find the f of 0. What's inside the parentheses? That's f of 0. So what's f of 0? Well, my x equal to 0 is right here. This is my x equal to 0. Now the corresponding y would be, again, you take like a vertical line, and this is f. So you need to find the intersection with the red graph, the graph of f. So the intersection with the red graph would be right here, this is actually 2, right? So the intersection with the red graph would be this point. So f of 0 is actually 2, right? This is, it's 2. So this is, there's g outside. Okay, we need to keep the g, and inside the parentheses, f of 0, which turns out to be equal to 2. Now we need to find g of 2, right? This is big because this is a g outside. So now g of 2, we're gonna go to x equal to 2. So here's my x equal to 2, right? This is my x, it's 2. And there's a corresponding output y using the function g, of course. The function g is the blue one. We're gonna go with the vertical line, and we need to find the intersection with the blue graph, not the red. Okay, the blue, that's the graph of g. So the intersection with the blue graph would be like this point right here, which corresponds to then -5. The corresponding output y is -5. So the answer here would be like -5. All right. So yeah. So then for the BF composed with f of 1 is, I mean, the idea is the same, right? Just instead of g, you have f. I mean, twice. Yeah. All right, guys, we have 2 minutes. Is there any questions? I think, as I said, number 7, it's not, that's a section 2.1, it's not in the test, so you can just forget about number 7. Is there any question, guys? I can answer them like in the last 2 minutes.
Yes, I have a
think-
question.
Yeah, please. Yeah.
Are you gonna provide us with paper, or like, because I use like a lot of space to solve these problems? Or is there gonna be space on the test, or are you collecting our scrap paper, or?
Actually, I cannot, well, I don't collect the scrap paper, but yeah, you need to bring some sheet of paper if you need like a lot of space. You know,
Yeah,
so
because there's not enough space in like the homework sheets that you sent.
no, well, in the test you're gonna have like more space. I mean, I try to do my best to like to provide you like a lot of space, but if the space is not enough, of course, then you need the extra sheet, right?
Okay.
Yeah. So yeah, please bring extra sheet of paper. I guess you're gonna need them, but I don't collect the scrap paper, of course.
Okay, and then the problem 7 on the
review sheet?
review. I know you said it's not gonna, because we didn't review
Yeah,
it.
yeah.
We didn't talk about it. But didn't
Yeah.
we talk about this in the last, our last
No,
math?
this is
something different?
Something, yeah, kind of different. Yeah, this is quadratic functions. It's a section 2.1. So yeah, I mean, I know you can probably answer like probably the B, the x-intercept, y-intercept, but no, I mean, no. So it's not. Yeah, it's not.
So you don't want to put it just like, maybe we can get a couple points, extra credit, put it on the test?
No. That would be
Okay.
unfair. I mean, if some, no, probably that would be unfair. I mean, because I didn't cover it. So, yeah. All right, guys. Any other question? So I think you should expect I think there will be like 8 problems, same thing, like almost the same thing in the test. You should expect like 8 problems. And of course, if you finish your test, you can leave the classroom. All right. Yeah, but I think you're gonna need every minute. All right, guys. I'm gonna stop here, I guess. I'm gonna check the chat if there's any question in the chat. Sorry, guys, I missed a couple of questions in the chat. We're gonna do all these in less than 2 hours on Wednesday, Richmond. Yes. The answer is yes, but I mean, I think they're gonna be, the questions are kind of short. But yes, that's what you have to do on Wednesday, because now you see, because I'm giving all the details, so it seems like it's a kind of long. But I mean, if you know your stuff, you know how to solve the problems, then it's gonna be fine, I'm sure. When you solve a domain, if there is a square root, that means it's included, right? Yes, yeah. When we have like a square root, you include the x, like you have x larger or equal to something, yeah, then you include the number, yes. All right, guys, any other question?
Professor, I have a question.
Yeah, please. Yes, I hear you.
Hold on, I'm tapping it.
Oh, okay. Richmond, I will send you the contact information of the of people in the administration to fix your problem with the WA grade. Guys, is for some reason you cannot enter the campus on Wednesday, please let me know in advance, all right? I can send you the test probably on online, okay? The questions on the exam, again, I said it's I think it's there are gonna be eight problems. But it's again, it's just kind of similar to the what we did today. Okay. Yeah, we're gonna have about 8 problems. Any other question, guys? Okay, I guess I'm gonna stop recording the meeting. Okay, stop recording.